Okay, so 7-6, what we're doing is factoring still, opposite of foiling still. But what we're doing today is factoring what's called special cases. There's two special cases. So the first one you sometimes don't even recognize till it happened. So if we just do what we've been doing, x squared would have us start with x's. Then where do we look for signs? First usually.
The last one.
We usually look at the last sign first. If this is a plus, it tells us they're the same as each other, as well as
Positive.
the first sign. So we go plus plus. And when the signs are the same, we try to multiply to make this always. But when the signs are the same, we're doing what to make that number? Trying to add. So what number pair can do that?
3 and 3.
3 and 3. And that's a little bit different. We've never quite had that happen before. That's what's called a special case. It's one of our two special cases. So if you're doing this the old-fashioned way, you get to that point, you break out your eraser, and you just write this a different way. I'm going to write that a different, simpler way.
X plus 3 squared.
Write it as x plus 3 squared. What this type of problem is called is a perfect square problem. Sometimes after you do a few of these, you can sense them. What you could look to do to get the 3 working is try to square root the last number, take half of the middle number, and in this case, half of this makes
3.
and the square root of that makes
3.
If that is what you have, you just stumbled into a perfect square problem. So if you see that coming, now that we have that experience, that's fine. But if you do it the old-fashioned way, what you're just going to end up with is 2 of the same, and then just rewrite it as a square. So it doesn't really matter if you see it coming or don't. Question about that. What do you think's different about this one?
Just have a minus.
Same thing, but with a minus. So we go x minus 3 squared, and we're good. This, if we did it the old-fashioned way, we'd stumble into a square, but if we wanted to check that, what were we talking about doing with this number? Square root that number, which makes us think of 5. Do what to this number? Half of it, which makes us think of 5. Since those agree, it is a square involving 5. And it would be
X minus 5.
x minus 5. Question about that? This one won't cooperate as well with that square root half trick, because the square root of 24, half of this is 12, but it's not the same as this. But this is still going to be a square problem. Tonight's homework, you have the advantage of knowing the whole group, it's going to be square problems. Okay, so it kind of gives it away. But if you get a test of mixed lessons, it's not as much of a giveaway. So something like this, you're probably stuck just trying to work how we've usually worked. With 9x squared, we take a guess, probable guess, 3x, probable, especially on a day today where we know it's going to be squares, we know they'll be the same. This, I copied something wrong when I did this problem. That should have been a 16, I believe. Yeah. So 16, your guess would probably be 4 and 4. With this as a plus, we know they're the same as this, so minus those. And then how did we check those when we were doing the guess check system? Oil. Foil or oil. So this would make 12. Those will make another 12. Together, 24. So if you bump into a twins like that, we know that that's a square. This, there's no real simple immediate check to make sure it's a square. What you'd have to do is like square root the first term to make a 3x, square root the 16 to make a 4, multiply these two is 12, and then what did we do when we were squaring things out? After we multiplied them with each other, how did we make the middle, remember? You add it to itself, or in other words, double it. So if you multiplied them, it's 12x, that would make it 24x. That is a square. But it's harder to see that one coming. You might just bump into it by accident. About that. But on a homework where we're guaranteed squares, the 36 came from 6 times itself. The x squared came from x times itself. A 49 from 7 times itself. The sign we go to this is plus. And if you want to make sure that's right, multiply these, and we're thinking 42, add it to itself or double it, and that would make 84, and then we're good. Something about that. So same thing, one more time, 64 came from 8, x squared from x, sine, minus, 100 from 10s, y squared from y's. But to be sure you're right on a test setting and not on a setting where it's like rigged to work, multiply them, you're thinking 80, and then double it. It is 160, that is a square, and we're good. Something about that. Small change, if that were like a 12, this would become a 6, which means that would have had to have a 6. Or if this were a 20, this would be a 10, which means this would have had to have a 10. I think there's a couple in the homework that they go big powers on. Question about the first special case. The second special case has a name, and it's easier to see, and it's easier to do. The perfect squares are a little bit weird sometimes. I've given this name before. Does anybody remember what the name of this was when we were going in this direction? It was a group when we were foiling that I just said we could fool it. Instead of foiling it, you could get away with just the fool part. Memory to that. They all have subtract signs. What's the word from 7th grade? Subtract. The answer is called difference. So this is a problem type that's called a difference of sum. Memory flash? No, it is an S word, though. It is the difference of squares. So what this means, if you want to jot a note or two or whatever down, it means the powers have to all be even. Because what were we doing to the powers a minute ago when we made the factoring move? Dividing them by 2. Cut them in half. So the powers have to be evens, so we can cut them in half, divide them by 2. And the numbers have to be like square rootable numbers. So with x squared, we'll go x and x. 9 comes from 3 and 3. Signs go one of each. Because if we did I'm only going to do this once, but if we did want to FOIL the check, this would be a positive 3x, and that would be negative 3x. And those two would just wipe out, so no one cares about that. So what you can do is, as soon as you see it's a difference of squares problem, just make the signs be different. Take the power, cut in half. Take the number, square root it, which would be
4.
And then just walk away. It's always going to work. You don't have to even check it. The positive 4x, the negative 4x, they're going to eliminate each other. So how would this next one go?
X plus 5 and X minus 5.
X plus 5 and x minus 5. Anybody confused by what happened? Different voice? Do that one for me. It's only 4 voices to choose from because other people are doing quizzes and they're occupied and doing other things.
2x plus 7.
It's the same voice. Yeah, we're going to go 2x. And then just go finish that one and then we'll pick on other people.
Plus 7 and
Yep.
minus 7.
Plus 7 and minus 7. Does anybody need a reteach to understand what that person just did for us twice in a row? Let somebody else do some work.
30x.
Yes?
And then it'd be, plus and minus,
Yes.
different ones. Then 8. But yeah, you have to add those variables.
3x, 3x, plus, minus. I'm with you on all of that.
And then 8y.
8y is right. Yeah. Question about what he did there? Somebody else take a turn.
32.
Not 32. 8, yes. 64, we got to square root it, so we're thinking 8s. Yeah, keep talking.
Plus
X5s, because we're cutting in half.
plus minus.
Different signs.
And then 9y to the 4th.
9s for that, and y to the 4th for that. All true. Yes, 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 and yes. Question about that? That was a little combo effort. We'll just take anybody. Okay, 100 gives me 10s. I might need a little more space there than I gave myself. I made this look pretty big. So 100 is 10s. X's, 3s. Y's, 4s. Z, 5. And I still didn't give myself enough space, did I? Plus, minus. You know what's going there because I'll just put it over there. 11 is true. 11 times 11 is 121. A, 3, B,
7,
C. And you probably would buy them if you had a whole test with like 50 of those. That'd be a nice test. Those are pretty nice to do. Power cuts in half. Signs are different. Square root the numbers. Make twins. Just make sure the signs are different so they're not identical twins. They're fraternal twins. Question about the scheme. Homework page on this life. We're working 290. So 290, we're going to start at 7. What they did on the first 6, I just don't feel like doing. The first 6, they just asked you, is it a perfect square? And some they were and some they weren't. So it would be like, if I changed this to any other number, it would be a no. If I changed this to any other number, it'd be a no. The 9 and the 6 are the only friendly pairing that's going to make that go together to make 3. 3 works with both of those numbers. But the first 6, they're playing yes-no games. I just don't feel like it. So we're going to go from 7 to 24, skip a few, because they get back to playing the game again saying, is this a difference of squares? If I made any of these powers odd, you'd say, no, I can't do it. Or if I gave you any numbers that weren't like square rootable numbers, you'd say no. I don't feel like playing a yes-no game in the middle, so I'm just skipping that and going to 33, working up to 38. It looks like the perfect squares go from 7 to 20, and then they switch it up on 21. From 21 to the end looks like the difference of squares to me, so you don't even have to think too much about what type it is. They come out of the gate with a bunch of these right in a row, and then when you get to 21, you get a bunch of these in a row. What's another real obvious difference? You can tell it's this kind, not that kind.
They're smaller.
They're smaller. It only has 2 terms called binomial, whereas these have to be trinomials. So as soon as you see the homework switch from trinomials to binomials, you know that they crossed over that line. 290, 7 to 24, 33 to 38. That's all we got. Thank you, camera woman.